to physics class online. Please subscribe to this video, hit the like button and turn on the notification bell. Well, today we'll be looking at dimensions of physical quantities. As I said in previous class, that's going to be our next topic. Now, remember in previous class we talked about introduction to physical quantities. I said physical quantities, they are subdivided into two. We have the fundamental quantities and then we have the derived quantities. Now, every quantities we'll be talking in physics, they are physical quantities because physics studies matter, and matter exists in three states, and those three states, they are physical states, which are solid, liquid and gaseous states. Now, today we'll be looking at dimension, as I earlier said. Now, what is dimension? Let me just bold the screen so that you can see clearly. Now, what is dimension? Dimension simply denotes the physical nature of a quantity and how it is related and associated with the three most important fundamental quantities, which are mass, represented in m inside and a bracket like that. Then we have the length, represented with capital L, and time t. Now, we have three most important fundamental quantities. Now, why do we say that these three quantities are the most important fundamental quantities? They are most important out of the 7 fundamental quantities. It's because most derived quantities, they are formed from these 3 fundamental quantities. Let's look at the next chart and next slide. You'll see what we're talking about. Now, if you look at these derived units, or let me say derived quantities, like area, if you look at the base unit, we have the meter square. If you look at volume, if you look at the base unit, we have the meter cube. If you look at the quantities, the derived quantities here, and you look at the side, look at base unit, you discover that the base units are measured these 3 most important elements, which is mass, kilogram, length, which is meter, and time, which is seconds. And that is why we say, since most of these derived quantities, they are made of these 3 fundamental quantities, that's why they are regarded as the most important fundamental quantity. Now, let's look at how do we deduce the dimension of physical quantities. Now, let's look at the next slide. Now, as I said dimension of physical quantities, the dimension of the physical quantities is the way that quantity is related to mass, length, and time. And the dimension of unit of mass, as I earlier said, here mass is m, length is l, and t is time, as seen in the table below. If you look at mass now, the mass, the unit is kilogram and the dimension is m. The length, the unit is meter and the dimension is l, and time is seconds and the dimension is t. Now, let's look at how we deduce the dimension of certain quantities. Now, let's look at, for example, number 1, density. Now, before I proceed, I want you to know that there are 2 ways to deduce the dimension of physical quantities. There are 2 ways to determine the dimension of physical quantities. Number 1, we can deduce dimension of physical quantities by knowing the formula of that quantity. For instance, the dimension for density, the formula is mass divided by volume. Density as a formula is mass divided by volume. So to know the dimension of density, if I know the formula to be mass over volume, then what I will just do is what? Know the dimension of mass and know the dimension of volume. By the time I know the dimension of each of the 2 of them, then I'll be able to know the dimension of density. Like in this example now, the density dimension, the equation for density is mass over volume. And what's mass? Mass is kilogram. And what is volume? Volume is meter cube. So let's now look at it. What is the dimension for mass? Mass is kilogram. And remember, dimension in the table above, mass represents m in dimension. So kilogram now is represented with m. And when you look at volume, volume simply means length times breadth times height. And it is length times breadth times height. Both length, both breadth, and height is talking about dimension for length. They are still, the 3 suggest the length. And therefore, we have L raised to power 3. And in other words, we can now say the dimension of density is ml raised to power minus 3. Just writing it in an index form, in form of indices, in an index form, then we have ml raised to power minus 3. And that is how we deduce dimension. Now, let's look at example 2. Example 2, let's look at velocity. Dimension for velocity, if I want to use the formula, dimension for velocity is displacement over time. And what does displacement suggest? Displacement suggests length. And why time suggests dimension of time is time and seconds. Alright, now if I want to use that, I will just say L to represent, because displacement is length, and then we can say L. While time is seconds, we can say T. So writing it in index form, we have LT raised to power minus 1. And what is the dimension for acceleration? In terms of formula, acceleration is change in velocity over time. Now, velocity itself is another broad statement or the items that we need to break down. And since we previously said that velocity is now displacement over time, so therefore the dimension of velocity will now become lt raised to power minus 1 divided by time, because velocity itself is lt raised to power minus 1. And if time, remember, is over time, then we have the second t as you see in this chart. Then we have lt raised to power minus 2. Then we have force. According to the formula, force is mass times acceleration. And remember, mass is in kilogram and dimension is represented in capital M, while acceleration has already been deduced as lt raised to power minus 2. And therefore, when you bring it together, then the dimension for force is going to be mlt raised to power minus 2. Now, if you look at the table below, gives the chart of some examples of some physical quantities and their dimension, like we see. All right, I believe you understand this, but for further explanation, I have decided to add a video to this explanation. Just sit comfortably and enjoy the video. Please don't forget to like my channel, like this video, turn on the notification bell so that you'll be able to enjoy more of our news. All right, thank you.
Trick to find dimensional formula. I will teach you the super easy trick to solve easy level and hard level questions. Firstly, I write here mass, length, time and current. We know that the SI unit of mass is kg, that of length is meter, that of time is second, and that of current is ampere. The dimensional symbol of mass is m, that of length is L, that of time is t, and that of current is A. Now consider this question. Find the dimensional formula of velocity. Well, we know that velocity is equal to displacement upon time. We know that displacement or length is the same thing. The dimensional symbol of length is L and that of time is t. Now I shift t from the denominator to numerator. I get square bracket L t to the power minus 1 square bracket, or I write square bracket m to the power 0 L t to the power minus 1 square bracket. Remember that this m0 means that mass is not present in velocity. Hence the dimensional formula of velocity is m to the power 0 L t to the power minus 1. Secondly, find the dimensional formula of acceleration. Well, we know that acceleration is equal to change in velocity upon time. Now velocity is equal to displacement upon time, then this time. We know that dimensional symbol of displacement is L, that of time is t, and that of time is also t. I get L t to the power minus 2. Hence the dimensional formula of acceleration is Lt to the power negative 2. Thirdly, find the dimensional formula of force. Well, we know that force is equal to mass into acceleration. The dimensional symbol of mass is m, and we have already calculated the dimensional formula of acceleration, which is Lt to the power negative 2. I get m L t to the power negative 2. Hence the dimensional formula of force is m L t to the power negative 2. Note down all these dimensional formulas which I will directly use in hard level questions. Now consider these hard level questions. Find the dimensional formula of pressure, stress and modulus of elasticity. Well, we know that pressure is equal to force upon area, and that of stress is force upon area. Now I write force upon, we know that area is equal to length and to breadth. We have already calculated the dimensional formula of force, which is ml t to the power negative 2. The dimensional symbol of length and breadth is L and L. This L and this L squared cancel out. I get m L to the power negative 2 t to the power negative 2. Hence the dimensional formula of pressure and stress is square bracket m L to the power negative 2 t to the power negative 2 square bracket. In case of modulus of elasticity, its formula is equal to stress upon strain. We all know that strain is unitless. We get modulus of elasticity is equal to stress. We have already calculated the dimensional formula of stress, which is m L to the power negative 1 t to the power negative 2. Hence the dimensional formula of modulus of elasticity is m L to the power negative 1 t to the power negative 2. So these three physical quantities have the same dimensional formula. Thus note down all these dimensional formulas. Secondly, find the dimensional formula of work done, energy, torque and kinetic energy. Well, work done and energy are the same, are two faces of the same coin. We know that work done is equal to dot product of force and distance. We have already calculated the dimensional formula of force, which is ml t to the power negative 2, and the dimensional symbol of distance is L. I get ml to the power 2 t to the power negative 2. Hence the dimensional formula of work done and energy is square bracket m L to the power 2 t to the power negative 2 square bracket closed. In case of torque, it is the cross product of force and distance. The dimensional formula of force is m L t to the power negative 2 and that of distance is L. I get m L squared t to the power negative 2. Hence the dimensional formula of torque is ml squared t to the power negative 2. In case of kinetic energy, it is equal to half of mv squared. Remember that we do not consider constants and dimensional formula. The dimensional symbol of mass is m and the dimensional formula of velocity is lt to the power negative 1. I take square root on it. I get ml squared t to the power negative 2. Hence the dimensional formula of kinetic energy is also ml squared t to the power negative 2. Thus remember that the dimensional formula of all these quantities is the same. So note it down. Finally, find the dimensional formula of resistance, reactance and impedance. Well, according to Ohm's law, V is equal to IR or R is equal to V upon I. Let this is equation number 1. We know that voltage is equal to work done upon charge. Also we know that charge is equal to I upon time. So I write V is equal to work done upon charge and to time. We already calculated the dimensional formula of work done, which is ml squared t to the power negative 2. The dimensional symbol of current I is A and that of time is t. I shift at from the denominator to the numerator. I get ml squared t to the power negative 3 into a to the power negative a. Hence the dimensional formula of voltage is ml squared t to the power negative 3 a to the power negative 1. Let this is equation number 2. Now I plug in this equation number 2 and equation number 1. R is equal to the dimensional formula of voltage is ml squared t to the power negative 3 a to the power negative 1 upon the dimensional symbol of current is A. I get ml squared t to the power negative 3 a to the power negative 2. Hence, the dimensional formula of resistance, reactance and impedance is ml squared t to the power negative 3 a to the power negative 2. Also remember that the dimensional formula of Boltzmann constant, entropy and heat capacity is ml squared t to the power negative 2 k to the power negative 1. While dimensional formula of angular velocity, frequency and angular frequency is m to the power 0, l to the power 0, t to the power negative 1. Thus note down all these important dimensional formulas which will help you in any exam. I hope that you have learned this super easy trick.